Hi everyone, this is Mr. Kestel. This video is about electric charge. If you are trying to find information about electric charge, you're in the right place. If you are looking for other information, you can look for the links in the description to get you to the right video. If you can use this video to help you figure out what the answers are for this district worksheet packet, there will be some questions on several pages that will use information covered in this video. So we're going to go ahead and get into that. Apologize for the rough transition here to the next point because I am adding this in after I already made the video. So here we go. Okay, so that title slide shows you that we're going to be talking about electric charge first. So the first thing we need to know when we talk about electric charge is that this has to do with particles in the atom. The atoms are made up of three particles. Okay, so the three particles in the atom, and I'm going to transition over to here, are electrons, protons, and neutrons. So protons, well, we'll do with neutrons first, because those have little to do with what we're going to talk about. So neutrons are neutral atoms or neutral particles in the nucleus of the atom. So they do not have a charge. So they don't really affect electricity, so we don't need to know anything else about them. Now, there's two types of particles that have charges. The first type is called protons, and these are particles in the nucleus of the atom that have a positive charge. So if we look at this diagram, that plus sign positive, they have a positive charge. Then the other type are electrons. Electrons are particles around the nucleus or outside the nucleus that have a negative charge. So what do we mean by positive and negative? Those are just words that were to describe a difference between the two. And they kind of help us with the math. So protons have positive charges, electrons have negative charges. Now this is not exactly how an atom looks, and the electrons don't exactly behave like this. Their movement is a lot more complicated, but thankfully in physics we don't necessarily need to worry about that. If you ever take chemistry, you'll learn a lot more about that. So the next question then is, how do these charges interact with each other? Well, I've got a little program here, and we've got two charges. Notice that if you look at the charge here and here, that both of these are negative charges. So if we look at the little guys look like they're pushing toward each other. So, and if I move one closer, they begin to push a lot harder. And you can see how hard they are pushing against each other. And the arrows here kind of point that they have to push against each other. The two charges are trying to push each other away. And if we change these both to be positive charges, same thing happens. So what we can learn from that is that particles with similar, we'll say like, particles with like charges repel each other. So what happens if the two charges are opposite or unlike? Notice when I change this over, the left one to be a negative charge, now the two little guys are trying to pull against it because the two charges are trying to pull together. They are attracted to each other. notice how the arrows are pointing toward each other. So the two charges are attracted to each other. So we would say that particles with unlike charges attract each other. So if you notice, again, as we get closer, as we move particles closer together, those forces, in this case that are attracting each other, seems to go up. They get stronger. So if they're far away, there's not much attraction, but as they get closer, they attract more and more. We call this an electric field. Whoops, let's go to the document. So their electric field, an electric field is the area around a particle that applies a force on a charge. Okay, so as the charges get closer together, the closer they are, the more force there is, so the field is stronger. Another way of seeing that is, whoops, forgot to reset this. If I put a negative charge right here in the middle, you can see all these little arrows pointing around it. And these arrows represent the field, the electric field around the charge. And if I use a little sensor here, notice way out here there's nothing happening. But as I get closer to the charge, there's an arrow. That arrow represents the force affecting the charge from the charge. That arrow represents how strong is the field. So if I get closer, the field gets stronger. To me, this kind of reminds me of the force of gravity. And if you're really close to an object, the force of gravity, the gravitational field around that object is strong. So on Earth, you know, we feel the gravitational pull of Earth. But if you were to go to the moon, then the moon would be the main gravitational field around you. So if when we have charges, they have an electric field around it, kind of like gravity. Now, the main difference between gravity and electric field is you can have an electric field that instead of pulls toward you, pushes away from you. But something similar happens. If you get closer, then the electric field is stronger, and if you get further away, the electric field is weaker. So, the electric field is stronger when close to the charge, and it's weaker when you're further from the charge. There's a whole equation for this, but we're not going to worry about that right now. So something you've probably heard of before that has to do with charges, electric charges, is static electricity. Now, what is static electricity? Let's see if I can spell it right. Okay. Static electricity is the accumulation or buildup of electric charges on an object. Now, if I was in the classroom, I would show you this in a couple different ways, but I do have a little handy thing here. So I've got a balloon and I've got a sweater, and we're going to see what happens when we rub the balloon against the sweater. Well, look at that. Look at the left side of the balloon here. You get all these negative charges. So when you rub the balloon against that, or for instance, if you rub it against your head, the electrons in the sweater, or if you're rubbing it against your head, the electrons in the hair, they can just decide to leave from the sweater or from your hair, and they jump over to the balloon. Okay, so that we can build up a set of electrons on the balloon. Notice it's kind of on the surface of the balloon, but it's only on the surface, this part of the balloon that is that touched the sweater. The right side of the balloon didn't touch the sweater and doesn't have any charges on it. So static, when we say static, static means it's still or doesn't move. Okay, so the electrons here are static; they're staying on the balloon. Okay, so when the balloon here touches the sweater, there is a transfer of charges. So we can transfer charges. So I'm going to say charges can be transferred by contact, touching another object. Okay, and this is sometimes it's called conduction. Okay, so just like with heat, when we had conduction, it was when two things were touching each other. Conduction here means that charges are transferred by contact. So, and if you notice, the positive charges on the sweater are now attracting the balloon, which picked up all the negative charges. So that's why the balloon is flying toward the sweater. Now, there's another way of transferring charge, and it's called induction. So notice what's happening over here on the right side when I move the balloon toward this wall. So this is supposed to be a wall over here. And if I move the balloon over by the wall, all the little blue charges in the wall, they kind of get pushed away. This isn't exactly how it works in the atoms, but it's essentially what's happening is all of the atoms, the electrons are moving, and we call that induction. So you don't actually have to touch something to change the charges. But notice, as soon as I move the balloon away, the charges all go back to where they were. So conduction kind of keeps the charges where they were, whereas induction, the charges are going to go back to where they were in the first place. This diagram here is kind of showing that. So I don't want to feel like going through all that actually, so I'm just going to ignore it. Okay, so induction. So charge can be transferred temporarily. There we go. When two charged objects get close, and we call that induction. So sometimes it's helpful to know if something has an electric charge, but you don't want it to lose the electric charge. You just want to know, does it have an electric charge? So there's a device for that. It's called an electroscope. And, scope. There we go. And this is a device that detects the presence of electric charges. So there's some pictures I found on Google here. Typically, you would have, well, back in the day, you would have some sort of bottle with some gold leaves or metal. Gold's a really good conductor. So gold leaves in here, and you'd have something on top. So you would move an object close to the top, and that would affect where the charges are at inside the material. And so, for instance, if you moved a positively charged rod, in this case, close to the electroscope, then inside the bottle, the little gold leaves would start pushing each other away. That was because the negative charges would come up to would be attracted to the positive charge of this rod, and that would cause the particles to the two gold leaves to separate. And actually, the same thing would happen if this was negatively charged. All the electrons would run away or move away from it because they're repelled from a negative charge, and so they would kind of collect at the bottom here, and you would see the gold leaves separate. So that's what an electroscope is. And there's more modern day ones now where we use digital electricity, readouts and stuff like that. So this is more of a historical thing. So to kind of summarize everything we just talked about, static electricity, okay, it occurs after electric charges accumulate on an object. Okay, so we had electric charges accumulating on the balloon and from the sweater. Okay, so electric charges accumulate on an object by gaining or losing electrons, and that's what static electricity is. Okay, so that's all the information we're going to cover for this video. The next video we'll get into current and resistance and voltage. We'll also have a video on circuits, and then the last video will be about power and batteries. And of course, have a wonderful day full of laughter and joy.